Now the continuation of motion in a straight line. See, we are going to learn through that motion in 1 dimension, 2 dimension and 3 dimension. See, what is 1 dimension? Which is nothing but the motion of an object is said to be 1 dimension. If suppose one of the 3 coordinates is required to specify with respect to time. It is also, we can call it as a rectilinear motion. In such motion of an object moves in a straight line. Example like train moving in a straight track, man walking in narrow or leveled road, that we can see. What is 2-dimensional motion? The motion which is nothing but if 2 of the 3 coordinates are required to specify the motion. In such motion of the objects which is in plane, 2 coordinates, and moving in the on a floor, a billiards, a ball moving on a billiard table, like that, right? 3-dimensional motion, which is nothing but the motion of an object is said to be 3-dimensional if all the 3 coordinates are required to specify with the respect to time, which is nothing but it takes place in space. Examples like a flying airplane or bird, kite, like that we can have a different examples, right? Now we can see that what is path length and the displacement. The path length, already before itself we have seen what is distance of path length or the displacement. The differences between the both, how we can see. See, the line joining the successive position of a moving body, which is called the path or path length, we can say. The length of the actual path between the initial and the final position gives the distance traveled by the body, the distance which is the scalar. Now see that with the help of the illustration you can understand more. See, the man which is covered first 5 kilometer, then he covered 2 kilometer. Then what is the distance? The distance traveled by the person which is 7 kilometer. Now again the man which is traveled 5 kilometer, and again the same path he covered the distance of 5 kilometer. Then what it will be the distance traveled by the person? 10 kilometers. See, that is nothing but the total path length which is covered, or the length of the actual path between the initial and the final position. You have to calculate the total. So that we can call it as distance. So what is displacement we can see? The displacement, which is the directed line segment joining the initial and the final. That means the shortest distance between the 2 points, which is when it started and it ends in the positions. That they have given that the directed line segment joining the initial position and the final position of a moving body. It is a vector quantity, so that it has the direction also, magnitude and as well as direction. Now the same person which is covered 5 kilometer and again he covered 2 kilometers. Now what is the displacement? Have to calculate the displacement here. The shortest distance between the 2 initial and the final position, what we say, that is nothing but it is a diagonal, or we can say the point of the displacement may be 6.57 kilometer in the direction which is shown by the arrow, right? Same like the person which covered 5 kilometer, again he come back to the original position 5. Then what is the displacement? Is 0. That means the shortest distance between the 2 points, the same position he comes. So that is the displacement value. Have you all understand that? Yes. Now see that some more examples. If a body changes from one position x1 to another position, then the displacement del x in the interval del t, that is equal to t2 minus t1, is del x, which is equal to x2 minus x1. So how can we say that displacement? So point number 1, displacement is a vector quantity. Displacement has The units of length, displacement of an object in a given time interval can be positive, 0 or maybe negative is possible. The actual distance travelled by an object in a given time interval can be equal or greater than the magnitude of the displacement. The displacement of an object between 2 points does not tell exactly how the object actually moved between those points. The displacement of a particle between 2 points in a unique path which can take the particle from its initial to final position, right? The displacement of an object is not affected due to shift in the original of the position time graph, the position axis. Okay. Now, we can see what are the differences between the distance and the displacement. The distance and the displacement. Distance, which is the scalar quantity, displacement is a vector quantity as we see. Distance, which it contains only magnitude, displacement also direction. So the second point, distance travelled by a moving body cannot be 0. And final displacement of a moving body can be 0. It is a scalar quantity, only the magnitude as we said. Examples, length, mass, time, speed, energy, which are the examples of distance. And the vector quantity, which is nothing but both magnitude as well as direction, which we said. Example, displacement, velocity, acceleration, momentum, force, etc. Now, the basic points which we have seen. The next one is what is speed? How the speed correlate or connect the distance and time. Now the time, rate of change of distance of a particle is called speed, or we can say the rate of change of position of an object with time in any direction is called its speed. It is equal to the distance which is travelled by the object per unit time. So speed, which is equal to distance by distance travelled by time taken, or we can write as a mathematical relation. V is the denoted letter for speed, that is equal to S by T. Now the speed is a scalar quantity as we said. The speed is either positive or 0 but never be negative, right? The speed of a running car is measured by speedometer. We seen in our car or bikes, is it right? The speed is measured in centimeter per second in CGS system, meter per second in SI units, right? Third one is kilometer per hour is a practical life when distance and the time involved are large units. So we can use all these three, right? Now what is uniform speed? The uniform speed, which is nothing but a particle or a body, is said to be moving with uniform speed if it covers equal distances in equal intervals of time period. See, however small these intervals also we have to calculate. See the example, it is covering equal distance in an equal time period. What is a variable speed? A particle or a body is said to be moving in a variable speed if it covers unequal distance in equal time period. So that also we have to consider a small of the units also. You see, it may be very speed or maybe very slow. Like a time intervals is same. Unequal distance it may cover, right? Now, what is average speed? When a body moves with variable speed, the average speed of the body is the ratio of the total distance which is covered or travelled by it to the total time taken, which is nothing but the total distance travelled by total time taken. Okay, we can say that if a particle covers the first half of the total distance with the speed a and half of that speed b, then what it will be the average? 2ab, which is equal to a plus b. If suppose a particle covers first 1/3 of the distance with a, second 1/3 of the distance with b, and the third 1/3 of the distance with c, then how can we say the average, the distance average or the speed average speed, which is equal to 3abc by ab plus bc plus ca. So this is for the average speed. The next one is, we can see instantaneous speed. See, the speed of an object at any particular instant of time, or we can say at a particular point of its path, which is called instantaneous speed. See the position time graph here, or we can, with the help of the position time graph, you can understand more. See, this is for the object which is at rest, the stationary object. The next we can see the object which covers the uniform, the position, the distance with the time. So this is called the uniform motion. And the next graph which shows the non-uniform motion, right? That we can see later what is uniform, non-uniform, which is nothing but the equal distance which covered by the time, equal time period. Non-uniform motion, which is nothing but the unequal distance, equal time period either, or equal distance, unequal time period, we can say. Okay. Yeah. Thank you, children.